Today we're talking about 8.2c, which is reviewing how to graph and write equations in our factored form. So just a little vocab review. Make sure you understand, right, that the name of our quadratic graph is a parabola. The axis of symmetry cuts our parabola in half. The vertex is the very middle point, and it's either the lowest, which is the minimum, or the highest, which is the maximum. This happens to be a minimum in this picture because it's the lowest value on our parabola. Our y-intercept, that's just where it crosses the y-axis. And then our x-intercepts are also our solutions, roots, and zeros. So those are all the same thing. So we've talked about how to solve in our factored form. So if we want to solve for x, we have two methods. We have the square root method and our box method with our factoring. So looking at letter A, 10x squared minus 1 equals 199, I notice that this is in the form ax squared minus c, right? I've got my a value or my x squared term, and I've got constants, but I don't have a bx term, right? Whereas in letter B, I do have that. So for letter A, since my only variable is that x squared, I can actually use the square root method here. Square root method, which means I'm just going to isolate x squared. So I'm going to add 1 to both sides. So I get 10x squared equals 200. Well, I'm going to divide by 10 on both sides. So I end up with x squared equals 200 divided by 10 is 20. So now that x squared is isolated, I can take the square root of both sides. Well, the square root of x squared is always x. That's why this method works. Square root of 20, well, that's not a perfect square, but I can break it down into 4 times 5. And then I end up with a group of 2 and then a 5. So I have a 2 that comes out of my radical and a 5 that's stuck inside. And then remember, we always have two solutions. So x could be a positive 2 square roots of 5, or x could be a negative 2 square roots of 5. Letter B, x squared minus 9x plus 20 equals 0, and we want to solve for x. Well, this one, it has that bx term in the middle, and so we have to factor this one. Right, so a is 1, b is negative 9, c is 20. So if I set up my puzzle, I need two numbers that multiply to be 20 and add to be negative 9. Well, I know that 4 times 5 is 20, so if I had negative 4 times negative 5, that would be a positive 20, and negative 4 minus 5 is negative 9. So that tells me my factored form here is x minus 4 times x minus 5. And since a was 1, I was able to use the shortcut. If you wanted to draw the whole box, you could. You would end up with those same factors, x minus 4 and x minus 5. So now we just have one step left. We have to set each of these factors equal to 0, and then we can solve. Add 4 on both sides, so we find that x could be 4, and then add 5 on both sides, we find that x could be 5. Those are our two solutions. So you need to know how to factor with the square root method, and how to solve with the square root method, and how to solve by factoring. Next, we've also talked about graphing in this unit, right? We want to be able to graph in factored form. So basically, we just need to fill out the information on the left, and that's going to give us everything we need in order to graph this on our coordinate plane over here. Here's my y-axis, here's my x-axis. So we have y equals negative times x minus 3 times x plus 1. So notice that our a value is negative 1. So since it's negative, this is going to open down. Well, then our roots, remember, that's the same as our solutions. So if we solve for x, we need to set our factor x minus 3 equal to 0, and then our factor x plus 1 equal to 0. So we get x equals 3 and x equals negative 1. So those are our roots, or our x-intercepts, 3, 0, and negative 1, 0. So I'm going to take a second and graph those. Here's my 3, 0. Here's my negative 1, 0. So our next step is to find the axis of symmetry. And there are two ways to do that. We could take our roots and add them together. So 3 and then divide by 2. 3 minus 1 would be 2 divided by 2 is 1. So the first way you can do it is to add your roots together and divide by 2. The second way to find your axis of symmetry is just to find that middle point between, right, the middle between your x-intercepts, and we see that 1, right, is halfway between -1 and 3 on our x-axis. They match up, which is good. They should. So then for our vertex, remember that we already have half our vertex, right? Your vertex is always on the axis of symmetry. So if you know the axis of symmetry, you know the x value of your vertex. And then to find y, all we need to do is plug in our x value. So instead of x minus 3, I'm going to have 1 minus 3. And instead of x plus 1, I'm going to have 1 plus 1. So then I've got a negative times -2 times +2. Well, a negative times a negative is positive, and 2 times 2 is 4. So we have the vertex is the point 1, 4, which would be right here on our graph. Okay, so last but not least, our table. We've got the points 3, 0, and -1, 0. Those were our solutions. And then we have our vertex 1, 4. So we need 2 more points because we always want to have about 5 points, just because that gives us a good sense of what our parabola looks like. So we just need to pick another x value. It really doesn't matter which one we pick. It just has to be something we haven't used before. I'm going to pick 0 so I can find my my y-intercept. I always like to find my y-intercept. So then I'm going to take 0 and I'm just going to plug it in to that original equation for x. So instead of x minus 3 times x minus 1, we'll have negative times 0 minus 3 times 0 plus 1. Well, then 0 minus 3 is -3, and 0 plus 1 is 1. -1 times -3 times 1 is a positive 3. So we get the point 0, 3. And then because our parabola is symmetric, we can just mirror that on the other side of our axis of symmetry. So we also find a point at 2, 3. And there's our 5th point. So to finish this off, we're just going to connect our points. Here we go, and it's opening down. Right? We have a maximum for our vertex, and it's opening down. And there is our graph. Make sure that you draw your arrows all the way to the bottom of your graph. Don't do any like short ones. Don't end it like that. You have to go all the way to the bottom. All right, next example. We also talked about how to have a graph and write the equation. So instead of having, let me back up here, instead of having an equation in factored form and graphing it, we're going to go backwards. We have this graph, and our goal is to end up with an equation that looks like this, with that y equals a times x minus p times x minus q. So the first thing we want to do is find our roots, find our p and our q. So it looks like we have a root here at -1, 0 and at 1, 0. So our roots are -1, 0 and 1, 0. Okay. And then this is opening up, right, because our arrows are going up. Either y value, right, it's getting positive. So it opens up, so we know it's going to have a positive a value. Looking at our vertex, right, our vertex is down here at 0, -3, and that's a minimum, right? That's a minimum because it's the lowest point on our parabola. So now we just need to find our equation. So right now, we've got our roots, so we've got our p and our q. So we have that y equals a times x plus 1 times x minus 1. And remember, the signs flip, right? The negative becomes a positive in our factor, the positive becomes a negative in our factored form. But we need to find our a value. So what we can do is use our vertex, here's my x, here's my y, and plug in our y value for y, and then plug in 0, our x value for x. And then you see what happens is we have all numbers except a is still a variable. So since a is our only variable, we can solve. So 0 plus 1 is 1. 0 minus 1 is -1. So we get a times 1 times -1 is still -1. So if we divide by -1 on both sides, -3 divided by -1 is a positive 3. So we have our a value. So now we just need to write our equation, which would be y equals 3 times x plus 1 times x minus 1. And that's our answer. Notice how all we had to do in order to write our equation, our equations are always going to be in this form, y equals a times x minus p times x minus q. So all we need to do to write the equation is to find a, p, and q. Right? P and q are pretty easy because you just have to look at your graph. A takes a little bit more work because you have to solve for a. Last but not least, example 4, we want to consider the equation y equals negative half times x minus 3 times x plus 5. And we want to create an equation that has one root in common, opens the same direction, and is wider. So if it has exactly one root in common, oops, I didn't mean to cross that out, I meant to highlight it. One root in common, that means we can use x minus 3 or x plus 5. It doesn't matter which one we pick. So we're going to use one of them, and then we're going to make up anything else for the other one. Doesn't matter what we make up, it can be whatever we want. Well, then we want it to open in the same direction. So if we look at our a value, negative half, right now it's opening down. So we're going to keep it a negative to keep it opening down. Then last but not least, we want it to be wider. Okay, well remember, in order to be wider, you need a smaller a value, right? The smaller the a value is, the wider it's going to be because it's growing really slowly. The bigger the a value is, the narrower it's going to be because it's growing really fast. So we want our a to be less than a half. So you could pick a third, a fourth, an eighth, a 16th, right? Anything that's less than a half. So there are going to be a lot of different options, so you could come up with a different example than what I have. Let's see, I'll make up 2 examples. So we could have negative 1/4 times x minus 3, and then I need to make up my own root, so I could do x plus 57. Again, you can make up whatever you want, as long as one root, they have that one root in common, right? They have negative x minus 3 in common. You can make up whatever you want for that other root. Or if we had used x plus 5, you could have done y equals negative 1/5 times x plus 5 times x plus 7. Right? Again, it doesn't matter what you make up, just as long as you have that one in common. So either of those are examples that fit these 3 criteria, but there are numerous other ones you could have come up with that fit the criteria. That's our review. That's everything we learned in Unit 8 so far. Make sure you ask questions if you have any.